Hey everybody. I think I've decided that on Fridays I'm going to try and do something that is related and somewhat interesting. So today I'm going to post a video about shock waves, breaking the speed of sound, something called bow waves. Should be relatively interesting, a little bit of a PowerPoint format unfortunately, and then there'll be directions to follow. So Fridays are going to be, hopefully, quote unquote, fun Fridays. So here's what's up. All right, so we've studied the Doppler effect and things we know about waves. We know waves are energy, and waves travel in a medium, meaning sound waves travel in air, right? So I'm talking to the camera, your computer is talking to you, and my sound waves are traveling in air. This picture here shows that. We've studied this a lot, where as this thing travels in the air, the sound waves bunch up. Well, you've all heard of breaking the sound barrier. So today we're going to talk about what that means and even show you what that means. So there is something called a bow wave. And as you can see here, this says when the speed of the source in the medium, so again, we're talking about air, is greater than the speed of the wave it produces. What does that mean? That means that if this little bug, if we're going to talk about air, if this little bug is traveling faster than the speed of sound. The speed of sound we're saying is about 340 meters per second. As these waves bunch up, you can see here the waves are bunching up. As he gets faster, now he's going as fast as the waves can travel. The waves are all bunched up. He's like right on top of them. And then bam! He is now going faster than the speed of sound. Now obviously this would be like a little bug in water or something like that, but the same principle applies. And now you can see here that this bow wave is formed where he is actually traveling faster than the speed, or faster than the speed of sound. There are planes that travel faster than the speed of sound. There used to be a commercial airline, the Concorde, that went from, I think, New York to London, that traveled at the speed of sound or faster. Jets, not aircraft carriers, those are boats. Aircrafts for the military. Lots of jets can travel faster than the speed of sound. So essentially a bow wave is the faster the source moves, the narrower, see this big V, this small v, the narrower that V produces, and you are traveling faster than the speed of the wave. Whoops. Now, what is a shock wave? A shock wave we know as a sonic boom. You may have heard them before, just randomly you're outside and all of a sudden there's a boom that happens. You don't really know what that is. That is a supersonic. What does that mean? Sonic means I can hear. Supersonic means I can't hear it. So it would be going faster than the speed of sound. When supersonic aircrafts break the sound barrier, there is this pileup of waves. And that pileup of waves is that boom, that sonic boom that you hear as the observer on the ground. So like you would see the plane, boom! And then hear the boom. This is literally a picture of what happens. Now, this only happens at low altitudes. You've heard me say before that we're going to use the speed of sound to be generally 340, I think I said 343 meters per second. And that's going to be constant for us. But there are things that affect the speed of sound, namely the medium that it's traveling, which you know. So when air is colder, the speed of sound is a little bit slower. When air is warmer, the speed of sound is a little bit faster. If there is condensation, like low level, say if you're flying right above the ocean, you can see this condensation cloud on the aircraft. And there are actually two of them. You see this, as this jet breaks the sound barrier, there are actually two little sonic booms, one for here and one for this guy. Now, one question you might be asking yourself is, does the pilot hear the sonic boom? I'm not going to tell you that. I want you to think about it and maybe tell me that. So now this is a 3-minute video. Yeah, this is a 3-minute video. I'm going to see if I can get myself out of the way. If you don't want to watch all 3 minutes, just take a look at the time and then fast forward 2.5 minutes or so. But it is really cool. It's just a video of a bunch of planes breaking the sound barrier. Right, so you saw that guy, as it was getting faster, that condensation cloud formed. and then notice you hear that little boom, that sonic boom. Notice they're all of these, this is the third one, are all right on top of the water.
Watch the vapor build up on this airplane. Look at that.
That one you heard the two sonic booms. Boom, boom.
Ladies and gentlemen, the Super Hornet high-speed pass.
Now again, just so you remember, as these planes are going really fast, those sound waves are building up, and that's actually the condensation. That's why you see that. It is building up, building up, building up, and you get this vapor, kind of like the vapor on the outside of a glass in the summer, that condensation. That's what's happening with these condensation clouds. They're just so pushed together, and then there's a temperature drop around the plane where it happens. There's about a minute left of these if you're still watching and you want to fast forward a little bit. That one's cool.
Yeah, he got it.
And that's all about sonic booms. Now we're going to go on and learn a little bit more about them. Now that you saw a bunch of videos of producing these shockwaves, we're going to actually learn a little bit of how they're produced, what's happening, more than my voiceover. This is another 3-minute video, and remember, everything that we've learned about waves, mechanical waves, also holds true for light waves or electromagnetic waves. And at the end of this 3-minute video, which is information, there's a narrator, and I will go back and talk about some of the things that they talk about. There's a really cool demonstration of light waves happening with a similar thing to that sonic boom. So we want to talk about that too. Sonic booms again. You already saw that video. That guy didn't make that condensation cloud.
Sound travels at about 760 miles per hour, or 340 meters per second. That's about 661 knots on an average day at sea level. And sometimes you can almost see it. Going close to that speed through air can cause some unusual visual effects. What you're looking at here is a NASA image of an SR-71 bending light waves from the pressure differentials it's producing. Air's pressure and temperature both drop when airspeed increases. Rapid changes in density can be enough to bend light like a lens. How does it happen? Airspeed increases as it flows over the form of an aircraft, pushing its way near Mach 1, the speed of sound. That means that even aircraft slower than the speed of sound can accelerate the air moving over them beyond the speed of sound. As pressure all around the aircraft drops, that air cools. And as air cools, its ability to hold moisture drops. So if there's enough moisture, you'll see it form in clouds that appear attached to the aircraft itself. But the cone-shaped clouds you see aren't in fact traveling with the aircraft. Each section of air is spontaneously reacting to the temperature and pressure change induced by the aircraft's body sliding past. Then there are the shock waves. Shock waves are formed by the air that can't get out of the way fast enough, forming a pressure wave. We perceive that pressure wave as sound. Aircraft actually usually produce two booms. They just reach us so quickly in succession that we can't distinguish the two. All of these factors are quite normal and have come to be expected in images that capture supersonic, transonic, or even near supersonic flight. But on rare occasions, we do get a glimpse of something special.
Now this is really cool. You have to
Kennedy
look
Space Center on
up towards the
February
top.
11, 2010, an Atlas rocket launched into ideal conditions for showing off shockwave. And this is the result. We hope you've enjoyed this little tour of visual and auditory speed of sound phenomena. Visit avweb.com for aviation news and inside information for pilots on an average day at sea level.
So,
And sometimes you can almost see it. Going close to that speed through air can cause some unusual...
all right. So here, what we have is this, the gentleman, the narrator, said we can bend light like a lens. What we're going to learn next week, bending light is called refraction. And bending of any waves, sound waves, are called refraction. And you're right, lenses do it. If you have glasses, we are refracting light, bending light waves so you can see better. And all this is doing is this is making the air molecules kind of organized in such a way that under the right circumstances, light is bent. Have I ever seen light bent? Absolutely. Have you ever seen light bent? Well, I just said if you wear glasses. I don't wear glasses. When do you see light bending? You see light bending in a rainbow. That is the bending of light. It is called refraction, and we're going to talk about it. All waves can do that, and this is just an example of that. So as things travel faster and faster and faster, again, those air molecules build up, and under the right conditions, we can see it. Under the right conditions, that supersonic boom, we can hear it. So all this is that application of a bow wave. Essentially, the air can't move out of the way fast enough, and when the plane bursts through, it is the crashing of all of those sound waves, all of that air rather, not those sound waves, all of that air coming back together, the air that couldn't get out of the way fast enough, that makes a boom. It's actually very similar to a bolt of lightning and thunder. Thunder is the sound the lightning makes. The lightning comes crashing down, and what it does is ionizes a lot of the air molecules, but it pushes air out of the way. The air comes crashing back in, and that's the sound of thunder. So hopefully this is a little bit interesting to you. And to end, we're going to end back with this picture. Remember, this plane, it's not an edited picture. Well, it might be edited a little bit, but this cloud is actually formed because the plane is traveling so fast. Now, the narrator said the plane doesn't actually have to go fast as the speed of sound, because the wings can accelerate, that means make the air go faster, accelerate the air molecules to be faster than the plane is going. And that's true. It's actually how we get lift of an airplane. It's something that's called the Bernoulli effect. So as that plane is traveling close to or faster than the speed of sound, the air around the wings is actually going faster. And I've mentioned this random chemistry equation before, PIV, PV equals nRT. As the pressure goes down because the plane is going so fast, we lower that air pressure, which causes this condensation. It is a really cool effect. It is physics in real life, and hopefully this was interesting for your fun Friday. That is all I have to yap at you about today. Please feel free, if you're watching on YouTube, to like, comment, or subscribe on the YouTube channel, and if not, comment on the Google website. Thanks, guys. Talk to you soon.